Gasoline octane ratings, a concept that everyone should know. First, some context. As to understand the octane ratings, first we must understand the combustion engine. So how does a combustion engine work? As you can see, engines use pistons to spin a crankshaft, and there are 4 steps in this process called the 4-stroke process. Step 1, which is called intake, involves a piston moving down, which creates a vacuum in the chamber. This vacuum sucks in air from the controlled intake valve, where at the same time fuel is inserted to make a air-fuel mixture in the chamber. Step 2 is called compression, where the intake valves close and the piston raises, in which the air and gasoline is compressed, where heat is generated from that compression. In the following steps, 3 and 4, 3 being combustion, the spark plug creates a spark, which creates a controlled explosion inside the chamber with that compressed air and gas, which automatically sends the piston down forcefully. Step 4, called exhaust, is when the piston rises again and the spent air fuel mixture is sent out of the exhaust valve, which leads outside of the exhaust pipe of your vehicle, as the name would suggest. So what does octane rating have to do with a combustion engine? In the 4-stroke process, a problem known as knocking can occur. Knocking is when the compressed air and gasoline combusts too early before the spark plug can ignite it. This creates a disproportion in the engine's timing, which creates a knocking sound coming from the engine. Such a problem can harm the engine and wear it down quickly over time. Thus, the octane rating is used to show how resistant a gas is to this phenomenon. So what is the octane rating and what does it mean to us, the consumer? Well, when you go to the gas station, the octane rating is used to indicate the resistance that a gasoline has to combusting too early. Some vehicles need higher octane levels due to how their engine is engineered. Perhaps the compression needs to be a lot more than other vehicles, or maybe the vehicle is very old and it has that problem very easily, so it might need a higher octane gas. This means that when you buy higher octane gas, which is usually more expensive, you are not getting a better gas mileage as many people believe. Rather, you're getting an octane level that is likely not suitable for your car. So what is the chemistry behind the octane rating, or the RON? RON, which means research octane number, refers to the resistance to ignition when it is compressed in the chamber, which creates heat. RON does not contribute to the power of the combustion engine, and RON is not the actual hydrocarbon octane, but rather the percentage by volume of isooctane, which is an isomer, and also in combination of N-heptane. And an isomer is when there's 2 compounds of the same formula, but the atoms are arranged in a different way, which create different properties. Thus, gasoline is rated based upon this mixture. So this is how the RON rating works. Gasoline contains over 500 hydrocarbons that are mainly straight chains. These straight chains tend to ignite too quickly, which would lead to the problem of knocking. That is why their octane level is really low. Thus, to counteract this, a cracking process is used to convert these chains into branched chain molecules which have a higher octane level, which means higher resistance to this problem. In terms of the specifics, when you take something like N-heptane, which is a straight chain molecule, you get an octane level of 0. And when you bring in isooctane, which contains 5 carbons and 3 metal groups, you get a rating of 100. Now it must be realized that neither 0 or 100 is a good rating for your car. 0 will be harmful, while 100 would be too expensive to sell. Thus, the ideal situation is to combine these to create an average octane that will fall into the required level for the combustion engine. As you can see in this example, there's a high performance car, and these vehicles use high octane gasoline as it is the most efficient gasoline for their engines because the engine is designed for that gasoline. So that's a nice little reminder about that concept. So here are some examples. Take 90% isooctane, which has a 100 octane level, plus 10% heptane mixture, which is 0 octane level, equals a RON of 90%. 86% isooctane plus 14% heptane mixture equals RON of 86%. Now we get 90% of isooctane plus 10% of N-heptane, which is containing a negative 20 rating, the RON will be 88. And that is because 10% of negative 20 is negative 2. Thus, 90 plus negative 2 is 88. So what about ethanol that's added to gas, as we do see? Now, when you take 80% isooctane plus 10% heptane plus 10% ethanol, you get a RON of 90.8. And to put this into mathematical terms, you're taking 80% of 100 plus 10% of 0 plus 10% of 108.6, which is the octane level of ethanol, which leaves you with the RON of 90.8. So remember, higher octane gas does not give you better gas mileage for your car. Check exactly what it is that your car needs to avoid your engine from knocking, and remember that RON is the average of isooctane and N-heptane. Remember that these hydrocarbons have different octane levels, which will affect the octane level of the fuel. Thank you for your attention, and I hope you will be well informed about your gas choices from now on.